The other thing we talked about today in class was naming acids, and before you can name an acid, you first have to be able to identify an acid. Acids will have a hydrogen at the beginning. Always there will be a hydrogen at the beginning. There is one very major exception to that rule, and we'll talk about it much later. But don't get too caught up in this. Acids have a hydrogen at the beginning, so keep that as a rule. In general, when you're looking at acids and you need to name an acid, the first thing you need to ask is, are there any oxygens in the compound, in the acid? So we're going to look at HF. So right now we can say no, there are certainly no oxygens in this acid right here. So if there are no oxygens, the first thing that you need to always write is hydro. And then we want to specify what the second atom is in this acid. So here we have fluorine. So we have hydro, and then we put in fluorine. But instead of that INE, we're going to use the IC suffix. So this is actually hydro, I don't know what I just wrote, hydrofluoric, and then we add the word acid. Okay, so these do seem a little bit simple, and in general they are until you start combining them with some of the other ones that we'll do. HCl is one that you've heard of and we've talked about before. You look at this, there are no oxygens, so you first use the word hydro. It is hydro, and then here you have chlorine, so it would be hydrochloric acid. Okay, another example would be H2S. Now, this one is a little bit different because here you've got two hydrogens. Keep in mind that this compound has to be neutral. So chlorine has a -1 charge, hydrogen has a +1 charge, it's neutral. However, here we have sulfur, which has a -2 charge. Therefore, we need two hydrogens to balance that out. Still, we're looking at this, there's no oxygens, so we're going to call this hydrosulfuric acid. Now, keep in mind, the only way to really get the hang of all of this naming business is to just keep on practicing, and I have put a couple practice documents up on the website and some practice references in the textbook. But just keep that in mind. Now, what happens if instead of no for are there any oxygens, we say yes, there are oxygens? Well, in that case, the suffix actually depends on what kind of polyatomic ion you have. So let's look at HNO3. The first thing we have to do is look at this NO3, and that's in our polyatomic ion reference list. And NO3 is nitrate. And since it ends in nitrate, ends in 8, we're going to change the ending to ic. So this is nitric. Okay? And keep in mind that since we have oxygen here, we don't include that whole hydro business. We're ignoring that completely. So we are really just calling this nitric acid. Okay? Since there is oxygen, we do not use that hydro prefix. Let's look at HClO2. So again, the first thing we need to do is, well, we are noticing that there is oxygen, so we're going to ignore that whole hydro business, but we have to identify what this polyatomic ion is. And if you look in your periodic table, not your periodic table, but your reference pages, ClO2 is chlorite. Now, notice that if your polyatomic ion ends in ITE, then you're going to change it to OUS. So this is not going to be chlorite, it's going to be chlorous acid. Okay, so you do need to remember, ite goes with us, ate goes with ic. All right, and again, this is just one of those things that you're going to have to keep on practicing to really get the hang of it. I'm going to stop the video there because we're going to do a lot more practice in class tomorrow. But also feel free to go to the textbook, the pages that I referenced. There are some practice problems in there, and I posted a website that has a list of practice as well. Now, keep in mind, if you have any questions, feel free to email me. But the best thing that you can do at this point is just to practice, follow the rules, and practice all of these. All right.